Microplastics in your arteries. Not in the ocean, not in a landfill, inside the plaque that lines the walls of your neck arteries, right next to your carotid. And the people whose plaque tested positive for plastic had 4.5 times the rate of heart attacks, strokes, or death over the next 3 years. This was published in the New England Journal of Medicine, March 2024. Here's what the research actually shows and where the honest boundaries of what we know sit. The study. Raffaele Marfella and a team at the University of Campania ran a prospective observational study of 257 patients who were already scheduled for carotid endarterectomy. That's the surgery where a vascular surgeon opens the neck artery and removes the plaque narrowing the vessel. The researchers took the removed plaque tissue and analyzed it 2 ways: electron microscopy to look for particles, pyrolysis gas chromatography to identify exactly what the particles were made of. The result: in 150 of the 257 patients, roughly 58%, they found detectable microplastics and nanoplastics inside the plaque itself, mostly polyethylene, the same material used in food packaging and plastic bags. 12% also had polyvinyl chloride, PVC, not on the surface, embedded in the plaque tissue. Then, the researchers followed all 257 patients for about 34 months. They tracked a composite endpoint: non-fatal heart attack, non-fatal stroke, death from any cause. The patients whose plaque had contained microplastics had a hazard ratio of 4.5 compared to the plastic-negative group. Statistically significant, wide confidence interval, but the direction and magnitude of the signal were unambiguous. Honest framing. This is observational data. It shows a strong association between microplastic presence in plaque and major cardiovascular events. It does not prove that the plastic caused the events. Patients whose plaque contained plastic might have other exposures that also raise their cardiac risk. Causal proof will require more studies, but this is the first human clinical evidence, published in one of the most rigorous journals in medicine, that microplastic exposure is showing up inside diseased human arteries and tracking with real outcomes. The tissue picture is broader than just arteries. Nyhart and colleagues published in Nature Medicine in February 2025. They analyzed autopsy tissue, brain, kidney, and liver. Brain microplastic concentrations were higher than either kidney or liver, and when they compared brain samples from 2016 to 2024, the brain microplastic load in brain tissue had risen by roughly 50% over 8 years. In autopsy samples from dementia patients, the brain microplastic load was 3 to 5 times higher than matched controls. Cross-sectional, autopsy only, association, not causation, but another emerging signal. The tissue distribution keeps expanding. Ragusa's 2021 paper in Environment International detected microplastics in 4 of 6 analyzed human placentas, first evidence they cross the placental barrier, moving from a pregnant mother into a developing fetus. A 2024 paper in Toxicological Sciences from Campen's group found microplastics in 100% of 23 tested human testicular tissue samples, and the concentrations correlated inversely with testis weight. So the picture is clear on presence in tissue, in multiple organs, across multiple populations, in samples collected across different countries and years. The obvious next question: how is the plastic getting there? And, more usefully, what does the research say you can actually do to reduce your exposure? That's next.
Here's what the research says you can actually do. Nothing removes microplastics that are already in your tissue. There is no validated detox, no supplement, no protocol that pulls plastic back out of an artery wall or a brain. That claim is unearned. What the research does support is reducing the incoming exposure, and a few sources are doing most of the damage. Start with heat and plastic touching your food. Every time hot food or hot liquid meets plastic, tiny particles shed off the polymer and into whatever you're eating. microwaving leftovers in a plastic container, pouring hot coffee into a paper cup with a plastic lining, bottled water left in a hot car. Move hot food into glass or ceramic before it touches plastic. Not perfect, just less exposure. Now, tea bags. Hernandez's 2019 paper in Environmental Science and Technology at McGill University measured what a single premium tea bag releases when steeped at 95 degrees Celsius. 11.5 billion microplastic particles, 3 billion nanoplastic particles, from one bag into one cup. Silky pyramid-style tea bags are usually nylon or PET plastic. Switch to loose-leaf tea in a stainless steel infuser or unbleached paper tea bags. Same tea, orders of magnitude less plastic. Water. COSUT's 2018 paper in PLAS 1 sampled tap water from 14 countries. 81% of samples contained microplastic fibers. Mason's 2018 study in Frontiers in Chemistry tested bottled water from 9 countries. 93% showed contamination, averaging 325 plastic particles per liter. Cox's 2019 estimate in Environmental Science and Technology put the average American at roughly 50,000 microplastic particles ingested from food and drinking water, and bottled water drinkers add another 90,000 on top of that. The practical filter fix. Reverse osmosis systems remove around 99% of microplastics from drinking water in benchtop testing. Undersink units start around $200. Countertop units like AquaTrue run around $450. Activated carbon block filters, the Berkey style or clearly filtered pitcher, reduce microplastics substantially, but not as completely as RO. Zero water pitchers work through a different mechanism. Pick whichever filter fits your kitchen and your budget. Any of them beats an unfiltered tap in this dataset. The rest of the daily exposure map. Stainless steel or cast iron pans instead of Teflon. Glass storage containers instead of plastic tubs, especially for anything you'll reheat. When possible, don't handle thermal paper receipts. Those aren't microplastics exactly. They're coated with BPA or BPS, hormone-disrupting chemicals in the same environmental exposure category. Different mechanism, same reduce exposure logic. And for seafood, wild-caught smaller species like sardines and anchovies sit lower on the food chain than farmed salmon or large predator fish, which means less bioaccumulation of the plastic loads found in commercial fish. None of this is perfect. Microplastics are in the air we breathe, the rain that falls, the soil where food is grown. Nobody living in a modern country gets to zero exposure. But the Marfella study is a real signal, published in the most rigorous cardiovascular journal on the planet. The direction of the science is pointing at exposure reduction as the practical move, while researchers work out the causal picture. The association is strong. Causal proof is still emerging. That's where the honest science sits right now. If you want to look at another emerging environmental exposure your body is quietly processing all day, check out our video on the everyday chemicals disrupting your hormones. The link is in the description below. This is research, not medical advice. Talk to your doctor before changing anything.